Our last example is going to be pretty interesting here, and let's read the question, maybe see why. It says, find the equations of the line's tangent to x squared plus y squared equals 9 at x equals 3 square root of 2 over 2. If you didn't catch what was interesting about this, it says lines, plural. So we're going to actually come up with two different tangent lines because there are going to be two spots on our curve that correspond to x is equal to 3 square root of 2 over 2. Let's see how this is possible. I'm going to make a little sketch here and then I'll explain the sketch. All right, there it is. Now, x squared plus y squared equals 9 is a circle of radius 3. This means if we were to go to x is equal to 3 square root of 2 over 2, that would be here. And there'd be another spot if we went straight down here, right? So not changing the x value. Yeah, we have another spot on this circle. So we're going to find the tangent line to this curve at both of these points. And in order to do that, we will need to take an implicit derivative, and we'll also need to know the y values at each one of these points. Let's start off with the y values. And in order to do this, we just need to plug in x equals 3 square root of 2 over 2 into our equation x squared plus y squared equals 9. So this looks like 3 square root of 2 over 2 squared plus y squared is equal to 9. And I'm going to scoot this up just a smidge. There we go. And now if we square this, well, if you square the 3, that'll give you 9. If you square the square root of 2, that'll give you 2. And if you square the 2, that'll give you 4. So we have 9 times 2 divided by 4 plus y squared equals 9. And we could take this a step further. Y squared is equal to 9 minus 9 halves. And 9 minus 9 halves is actually just 9 halves. And so we can finally solve for y here by using the square root property. And we can simplify this a little bit. We could rewrite this as what? The square root of 9 is 3, so 3 over the square root of 2. Or if we wanted to even go further, we could rationalize the denominator, so plus or minus 3 square root of 2 over 2. All right, well, now that we know the y values here, and we know the x and the y values, I should say, we can maybe find the derivative at those points now. Okay? And the reason we needed the y values is you might remember our implicit derivatives sometimes contain both x's and y's, so it's helpful to have both. Okay, so if we let's just make a little spot here for ourselves. I'll just write implicit derivative. And specifically, I'm talking about taking the derivative of this x squared plus y squared is equal to 9. Well, if we do that, the derivative with respect to x of x squared is 2x. The derivative with respect to x of y squared should be 2y times y prime. And the derivative with respect to x of 9 is 0. And we can go another step further. We could divide each side by 2, and that's going to leave us with x plus 2y. We divided by 2, right? So x plus y times y prime is equal to 0. And one last step on the derivative, y prime is equal to minus x divided by y. Okay. So we have another step down. We have our implicit derivative, which means we can find the slope of the tangent line at these 2 points. Okay. But we're going to have to plug in the corresponding x and y values. And I think I'll do that, I'll squeeze that in right here. So I'm going to say when x, y is equal to the 3 square root of 2 over 2, right? That's our x value for where we're looking for a tangent line. And one of the y values is also 3 square root of 2 over 2. Okay, so when xy equals this, the derivative is equal to blah. We'll figure that out in a second. Okay. But I'm also going to want to find the slope of the tangent line at our other point on this circle. How about 3 square root of 2 over 2 comma minus 3 square root of 2 over 2. And we're just going to use this little formula right here to find our derivatives. So if we do x over y, so it's minus 3 square root of 2 over 2. So there's our minus x. And then over y, which is 3 square root of 2 over 2, this just gives us minus 1. And if we do this for the second point, minus x looks like minus 3 square root of 2 over 2. And then y is already minus 3 square root of 2 over 2. So the slope here is going to be positive 1. All right, so we have our slopes. Now we just need the 2 tangent lines. Okay. Well, one of these tangent lines, right, goes through this point right here. Let's deal with this one. Okay. Y minus the y value is equal to the slope, right, that was minus 1, times x minus the x value of the point, so 3 root 2 over 2. So there's one of our equations. Let's write the other one now. The last one is y minus, and note the y value here is negative, right? So I'm going to write actually y plus 3 square root of 2 over 2 is equal to, and our slope of our tangent line should be 1, so I have 1 times x minus the x value, which is 3 square root of 2 over 2. And let's real quickly just go into Desmos and check and see if our tangent lines actually match up. Okay. See if they're actually the correct tangent lines. Now that we are in Desmos, you can see here on the left I have everything we really want already typed in. So I'm just going to turn all these things on one at a time. Let's start off with that circle. X squared plus y squared equals 9. Then we found 2 points on this circle that we were concerned with. And we wanted to find the tangent line at each one of these. Let's start off with the tangent line of this top one. We found it to be this next equation that I'm going to activate here. And you can see we found the tangent line. And let's see how we did with the other point. Looks good.